So this is the first, and what I maybe hope to be a series of videos where I kind of teach the basics of Linux to others to kind of reinforce the basics for myself, and just to kind of help people out. So this first video is about getting into the Linux box, the SSH basics. What kind of SSH scenarios might you run into? Why are they that way? And how would you navigate that, right? So before we get started, I just want to go over my environment real quick. And this is going to be the same environment I'm going to use for most of my videos. For those of you who are familiar with AWS, you can see I've got EC2 user here. So you already know I'm running a RHEL Red Hat Enterprise Linux 8 box on AWS, right? And I'm actually running it using Linux Academy's Cloud Sandbox. And they're not paying me to say this, but it's $50 a month, and I love it. I can boot up sandboxes all day. I can create instances. As you can see, I've got server 1, server 2. Server 1 is where I'm starting out. I can create an elastic IP address and attach it to this instance. So it's got a public IP that stays the same. I can connect to it from my house. I've got server 2. It's got a private IP. I can only reach it from server 1. So server 1 is kind of my bastion host, jump box, configuration host. I've set up DNS using Route 53. I've just got a basic domain set up with a record here for server 2. And I just did that for, I would say, ease for myself, because I didn't want to have to remember the IP address and type it in every time I wanted to connect to server 2. But yeah, so that's what I'm working with, and that's what I'm going to be working with. And I'll probably do a short video on how I set that up after this one. But so yeah, in most cases, you're going to be managing a Linux-based environment over the network using SSH. Most Linux machines don't come with a desktop, but they all have the ability, for the most part, to allow you to enable a desktop, but most people don't. You can do most of your work through the command line interface, through the terminal. Even if it has a desktop, you're probably going to open up a terminal, which is a bash shell, and it's similar to command prompt or PowerShell for the people coming from Windows. But if you really want to, you can VNC, which is similar to RDP for Linux, around to different desktops in your environment. But that's another video. So here I'm in a bash shell, right? Which again I said is similar to PowerShell or command prompt. And generally, when you want to SSH, you're going to provide the same SSH commands that you would in Windows, right? So it's going to be an SSH command. This most simplest scenario you're going to run into. You're going to run into 3 different scenarios. You're going to run into a scenario where the system requires you to just enter a password to SSH, or maybe the system requires you to enter a private key to SSH, or maybe the system requires a private key with the password for you to SSH. It all depends on how the system is set up, what options you need to provide, or what prompts you may need to respond to. So for the first scenario, most basic SSH scenario, is when you want to reach a remote machine, you're just going to type in the SSH command, and you're going to say a user that exists on the machine. So I know Bob exists on server 2.thesudo.com, right? And I can enter the password, or because I have DNS set up, I can do it this way, right? And it's going to ask me for Bob's password, and I'm going to say password because that's Bob's password. And now I'm in to server 2, and that was easy. That's the most basic SSH scenario you will run into. Now there is a second, so if I exit, right, I can exit that SSH session, and now I'm back to EC2 user on server 1. And there's a second scenario, like I said, where you may need to provide a private key, right? So the idea with SSH keys is there's a private and a public key pair, right? And you can make them yourself. So say I do ssh-keygen, and I hit enter. It's going to generate, see it says generating public and private RSA key pair, right? I can give this file a name. So my key, right? Well, let's just say .pem. If I don't give it a name, it will name it ID RSA by default. Oops. And whatever, it's not really good to do it that way, because if you're using the ID, the RSA key for something already, if you go ahead and do this, you're going to overwrite that, and then it causes a whole lot of work. You have to go back and recreate, replace that key on every system now. It's essentially useless at that point, the old ID RSA key. So I'm going to create a key, mykey.pem. And if I give it a passphrase, right, this will be that third scenario you run into, where when I try to use this key, I'll be prompted for a passphrase. And this is good, because this is the most secure. If I'm in an environment and my network administrator or my systems administrator says you can only log in with a private and public key pair to every machine, right? Well, that's pretty secure. But if somebody gets a hold of my key, they can use it to get into the machine. But if I provide a password to that key, now they need the key and the password. So they can have the key, but every time they try to get in the machine, they won't have the password. So it's two-factor in that way. It's pretty secure. So I'll just name this password, right? And it wants me to enter it again. And there you can see, your identification key has been saved in mykey.pem, and your public key has been saved in mykey.pub. So if I do an ls here, you can see the directory I ran ssh-keygen from is where my keys go. I can fix that. There are options you can provide to put that key in your desired directory if you want. But that's it's not necessary right now. So now I've got a private and public key pair. What do those mean to me? So the public key goes on everything you want to connect to, right? It's the public key in the way that everybody in the world can have the public key. Every machine can have the public key, but only you have the private key. Therefore, only you with the private key and anyone else with your private key, if you've been handed it out, can connect to an instance with the public key on it. If you try to connect to an instance without a public key with your private key, you can't. You need both pairs. You need public on one machine, and you need private on the machine you're trying to connect from. So EC2 user comes pre-installed with a key that I defined when I created the machine. All right, so if I try to SSH, right, I've already got the sudo-lab.pem in my .ssh directory for EC2 user, right? So to connect with the key, I'm going to ssh-i.ssh with this directory / the key name to EC2 user, right? And because the public key is already on EC2 user on server 2, it lets me in. Now, that key I created earlier, the mykey.pem, right? If I put that public key on server 2, then try to connect from server 1 using the same command, right? Oops, I'm on server 2. It's gonna prompt me for a password because that's the third scenario, right? And that's basically the basics of connecting with SSH. That's how you're going to connect to most of your machines in your environment. Now, if we look, I also want to kind of go over the the directory structure, because if I do an ls, like if I list all the files and directories right in this directory, right, I don't see anything related to SSH, right? However, if I do an ls-a, I can see all those hidden directories and files with the dot before them, right? So I see I've got .ssh here, right? So if I cd into .ssh change directory, I've got 3 files in here. I've got an authorized keys, a known host, and the sudo app.pem. And the sudo app.pem is the private key to the public key that I have on server 2 for EC2 user. And there's also an authorized keys file here. So if I go into authorized keys, right, you can see there's a key in here. And that was the key that was generated. It's the public key that was put on the machine when it's created, when I chose my private and public key pair. Generally, you don't want to use authorized keys because it can become a security risk, right? Authorized keys is you can put all your public keys for everything and everyone you want to connect to that user in authorized keys, right? So say I had 4 different public keys I needed to put in this directory for 4 different people to connect to EC2 user. One, that's not secure, but to make it even less secure, I might say I'm just going to put them all in authorized keys, and then I'm going to take that authorized keys file with all those users' public keys in it, and I'm going to pass it around to every machine. And that's an easy way for me to let everyone in my environment connect to all of my machines. But it's also an unsecure way. What if someone leaves? Do I now have to go to every authorized keys file on every machine and delete it, right? Generally, in a real environment, you're going to be using some kind of user store, LDAP, user federation, like Red Hat IDM, Free IPA, Active Directory, so you won't have everyone connecting to the same user. Everyone will have their own user accounts. Everyone will have their own key, and it won't be stored, locally on every machine, and the private keys won't be handed around, But I think that's it for now, and then maybe in the next video I'll go over, how I set up this environment using the Linux Academy sandbox on AWS, and maybe some SSH errors as well. So yeah, stay tuned.